Okay.
Okay, good evening, everyone. I am Keshav Samrat Modi, President SPI CSIO Chandigarh chapter. Today we are here to listen Dr. Marc Himel. He will be talking about harnessing light for a better world. Today for our talk, people around the world are joining. People from Indonesia, US, Egypt, Bangladesh, India. So I will now request our another one. After the talk of Dr. Hamill, we will take the question answer. So I request everyone to kindly post their in the chat box. So after that, we can take your question. Now I request our chapter advisor, Dr. Umesh Tiwari, to introduce our speaker, and then we will begin the talk. Thank you.
Very good evening to all of you. First of all, I welcome Dr. Marc D. Himel. It is my great privilege and honor to introduce Dr. Marc D. Himel. Dr. Marc is presently the Director of the Inside Sales and Customer Success at MKS Instruments. That is a subsidiary of the Newport. He has more than 30 years of experience to advancing the application of photonics to solve complex systems issues in semiconductor manufacturing, material processing, and other commercial and consumer applications. Before joining Newport in 2018, Dr. Marc performed the business development and product management at Gen Optics Optical Systems and Digital Optics Corporation, where he concentrated his effort on the development of micro optics for semiconductor, industrial, medical, and consumer application. Prior to this, he has also worked at SBZ lithography system and AT&T Bell Labs developing advanced lithography system. Dr. Marc received his BS degree in physics from the California Polytechnic State University. He has received his PhD in optical sciences from the University of Arizona and an MBA from the University of Connecticut. His research and development activities has resulted in more than 46 publications in the Journal of International Repute. He has 3 patents in his credit, and he is a elected fellow of SPIE in 2010. With this, may I now request Dr. Marc to deliver the talk.
All right, thanks, Dr. Tiwari. It is a great pleasure to be here with you all today. I have to confess, I would actually much rather be with you all in person. This will be my first time giving this talk virtually, and I really, like to visit the institutions that request me to do a visiting lecture, so I can meet everybody in person, see the labs, and get to know you a lot better. In some one-on-one discussions, after a talk where we're sitting down and having a cup of tea together. But it is, I'm thrilled with SPIE for their, putting this visiting lecture program on. And, I hope, at some point in the not too distant future that you're able to invite a speaker to come in and actually visit you. Of course, the advantage of this virtual format is that we can have people from all over the world attending, presentations such as this. And interestingly enough, it's all because of photonics technology that allows us to be together around the world virtually at a time when we're, all cloistered at home, during a pandemic. People often ask me, why did I get interested in optics? And so on this cover slide, you'll see, three photos, things. So in the upper left-hand corner, you'll see a picture of Jupiter with the Voyager probe. And when I was a kid in the late 70s, I was absolutely fascinated by our interplanetary probes that we were sending. And my goal, we had a friend that worked at NASA's Jet Propulsion Laboratory, and my goal was to work at JPL and send something into space and ultimately to be a principal investigator on some sort of interplanetary space program. As I was going through college at Cal Poly, getting my degree in physics, I was fascinated by rainbows, and I really wanted to understand where rainbows came from. And I didn't learn that in my undergraduate program, so I thought, well, I guess I should go and get a degree in optics, and maybe I'll understand where rainbows come from. Interestingly enough, after 3 years of courses in optics, nobody had taught me about rainbows. So when I was studying for my comprehensive exams, I started by learning how rainbows were formed in the sky, learned that they're very highly polarized, and was fascinated by that. The third thing that got me involved in optics was photography. My dad handed me a little twin reflex camera when I was probably 8 years old. No film in it, but I went around, around the house in the neighborhood pretending I was a photographer. And then eventually I could get film for a camera, and I've been taking photos ever since. And so that's kind of why I am here, at least how I got to into this field. Now the question is, I've been, as you heard from my bio, I've been around for a long time. So got my bachelor's degree in physics in 1984. So it's been some 30 plus years that I've been in the career of optics. What is it that keeps me here? What excites me about the field of optics and photonics? And so at some level, the talk I'm about to give is kind of the things that are important to me that keep me engaged in this field. And okay, slide not advancing. Let's see. There we go. All right. And so this talk basically came together, I think I gave it there the first time in 2008. And my goal at the time was actually to go back to my undergraduate institution and try to promote the field of optics and photonics as a career for people that were coming out of that institution in mechanical engineering, electrical engineering, and in physics. And that's why I put the talk together. And since then, the talk has evolved, and I've given it to corporations, people that have, with optical engineers, 10, 15, 20 years of experience as part of the visiting lecture program. I've given it in many places in the world, just kind of talking about some of these various topics. What's become very clear, is that since the invention of the laser in the 1960s, optics and photonics has really become the enabling technology of our society today. I'd say that the last century, the 20th century, the enabling technology was really electronics. Of course, without optics, there would be no electronics today, at least not as sophisticated as they are. This century, I think, is going to be the age of optics and photonics. And I'm going to try to do this little thought experiment, and I'm going to need your help. So maybe a couple of volunteers to unmute themselves, to maybe answer some questions. But the thought experiment is, since I just mentioned that the laser was invented in 1960, we're roughly 60 years into that invention. Let's do a thought experiment where we wake up tomorrow morning and we discover that lasers no longer work. And now we want to watch a movie. Maybe some new movie just came out at the cinema that we want to go see, or something. So maybe somebody. Okay, you guys are not hearing me. Yeah, I'm trying. Let me. Okay, let's see if this is better. Unfortunately, I don't have a headset that I can put on. All right. Okay, can you guys hear me better now? Okay, so I'll try to be closer to the mic. So the thought experiment again is, if we wake up tomorrow morning and lasers no longer function, kind of what happens, and we want to see a movie. So if I could get somebody what's the first thing you think about when you want to, watch or see a movie? Yeah. Keshav, how about you? You want to unmute and answer the question?
Yeah. If all lasers will shut down,
Well, that's what happened. Now let's just see, what would you normally do if you want to go see a movie?
I will book a ticket through internet, and
Okay. Okay, so you go to book your ticket through the internet, and what happens?
So if lasers were all shut down, then there will be no communication. This all internet line will be shut down. So
Exactly.
probably,
Okay.
yeah.
Yep. So you really want to see that movie. So what do you try to do next?
Yeah. Then I have to go to the that mall to book the ticket.
Okay, so you head down to the theater. You go in and
person. Yeah.
you go to buy your ticket. Do you typically pay for your tickets with cash or with credit cards?
Yeah. Then I have to pay the cash, obviously,
Okay.
because communication is down.
Okay. So you pay for your ticket, you get your ticket, you walk inside, you sit down, the lights dim, and it's a brand new movie. Does the movie come up?
No. So again, it depends on the satellite satellite signals and that internet connection. So lasers are down. That is also down.
Yep.
Yeah. So old projector
yeah.
technology.
Yep. So they used to send out reels of film, but they don't do that anymore. Now what they send out is you download it from the internet, which we've learned because of lasers, internet does not work. You could not use your credit card because even though you can slide your credit card through with a magnetic strip, there's no signal to the banks. You can't even go to the ATM machine and take any cash out. And so basically we just got rid of one type of optical component, the laser, made it so it doesn't function anymore, and our entire economy collapses. So, that's just one example. And as you can see, most people don't know that optics and photonics is the backbone of so much of our technology, that without it, we would not be functioning the way we are, today. And when I was first putting this talk together, I thought, ooh, that'd be a really cool story to tell. What happens if photonics didn't exist? And it got to be kind of very depressing. So I turned it around into this harnessing light for a better world. And so what I'm going to do is, go through and talk about various fields of optics and some very interesting and maybe unique applications in terms of social action that you may not be aware of that are, supported or even driven by optics and photonics. And I do need to say I'm an MKS employee, but everything that I'm sharing here, is my own views and opinions. It doesn't represent MKS's perspective. And with that, I'm going to switch topics pretty abruptly at times, but you'll see things from machining and healthcare and science and technology. And I hope that this gives you guys a sense for how broad our technology base is, where we are involved, and that you get and stay as excited about optics and photonics as a career as I have been for 35 years. Okay. So first I want to talk about is exploring our universe. And here I've got photos of several different telescopes, from the Hubble Space Telescope, which is, interestingly enough, optics' probably biggest failure and at the same time biggest success. I don't know how many of you were around and have kind of watched the history of the Hubble Space Telescope, but when we first launched the Hubble into space, turned it on, it didn't work. It had blurry images because we had fabricated one of the mirrors to the wrong shape. And it took a lot of time and money to send some people up into space to fix it and put in some corrective optics that would basically allow it to see as it was designed to see. And so our biggest failure, because basically it was a pretty significant mistake in how we polished the mirror. They were able to measure the amount of spherical aberration, and then they were able to go back into the facility that had made the primary mirror and found the corrector lens that they used to convert this aspherical wave into a spherical wave so they could do the interferometric testing. They found that module assembled, and they were able to basically do a detailed study of that unit to find out, to learn that it was assembled slightly incorrectly. A mirror and a lens were basically off in their positioning by about 1 millimeter or 2. So that it was misaligned and introduced the blur into the system. And they were able to figure out exactly how much blur and which direction it was, so they could actually design a lens mechanism, lens and mirror mechanism that could correct that. The remarkable thing is that the Hubble was originally designed with 1960s technology, and then they used 1970s technology to go in and create those corrective optics. And ultimately, when they put the CoStar module in place, the Hubble had better eyesight than its original design. And so we've now gotten some 30 years of science out of the Hubble Space Telescope that is much better than we would have gotten had we not actually screwed up. So again, our worst error and most visible error to people in the world, but also one of our greatest successes with the science. Advances in optics are now allowing us to make even larger telescopes. The primary mirror on the Hubble is about 2.5 meters. The next generation Hubble Space Telescope, the James Webb, is basically an 8-meter primary mirror here, made up of hexagonal segments. And where the Hubble went into low Earth orbit, so the space shuttle could get to it and we could fix it and update its technology. This is going to go 150,000 kilometers away or something like that. So it needs to work the first time, and it needs to work right. It needs to be built to last a long time without us going up and repairing it, which has introduced a lot of complexities, including delays. And hopefully it launches next year. At the same time, advances in optical technology with adaptive optics and basically being able to point lasers in the sky, use those to improve focus and deal with turbulence, is allowing us to make even larger Earth-based telescopes. And so here actually is a design for a 30-meter telescope on Earth. You can look down here, if you guys can see my cursor moving around, that's a car, and those are people standing up, just to give you a sense of scale. And so what we're expecting to see in the future from astronomical observations will let us peer further and further into the depths of our universe, to the edges of our universe, learning even more about the worlds around us. Optics also played a critical role in the discovery of gravitational waves. So this is one of the gravity waves observatory elements in Hanford, Washington. In the United States, there's another one in Louisiana. There's one in Japan. There's a few others that are being built. And basically, these use 40-kilogram mirrors to create a Michelson interferometer. It's a multiple path. The light bounces back and forth several times over these 4-kilometer distances. So this is kind of the largest interferometer in the world at the moment. And then you place them in different parts of the world, and you connect them up. And now, I'm an optical engineer. I'm not a physicist. And so they tell me that gravity waves, when they go through, they basically distort space-time. And that space-time ends up with a contraction of space in one direction and an elongation of space in the other direction. And if you see the same signal at 2 or 3 different observatories around the world, you say, yes, it's a gravity wave. And gravity waves are radiated by extreme events that happen in the world, in the universe. And I'm going to hopefully play now is the sound, because the gravity wave is a compressional wave-like sound of 2 black holes colliding. One of them with a mass of 33 solar masses, the other one with 31. And when they combine together into that one black hole, 3 solar masses of energy was radiated into this gravity wave. And that's what we're detecting some 2 billion years after it happened. And I don't quite know what happened to the sound there. Okay. Solar energy is another area that optics is playing an important role. Both in terms of trying to make standard silicon solar cells more efficient, putting nanostructures on them to absorb more light over a broader wavelength range, to condensing the light into small areas where I can put a small detector that has much better sensitivity and absorption of solar radiation over a much broader range. Here's another example out of MIT where light comes in vertically, gets trapped, it comes out to the edges, and then you would basically put your solar cells right along the edges. And so you end up using a lot less area size detectors to gather the light. A vision by Honda, is fuel, basically electric cars, charged up using solar power. So everything basically completely sustainable. No nuclear power, no coal-based power, petroleum-based power products used even to charge the cars. Whether we'll see that anytime soon, I don't know, but it's a nice vision. Another area of development is fusion power. This is a multi-billion-dollar facility at Lawrence Livermore National Labs. It's the Inertial Confinement Fusion Program. One method of generating fusion of basically hydrogen into helium, for example, is to bombard it with a lot of lasers. This is the test chamber for this. You have basically 192 laser beams all being focused down onto a small pellet of deuterium and tritium, and it heats it up until it's 100 million degrees and compresses it. And as that compression, it fuses together, and it generates electricity from that. Again, every time I talk to the people at Lawrence Livermore and I say, when are we going to have fusion energy as an energy source? It's 50 years from now. That happened 40 years ago, 30 years ago. So this is probably a long time to come. Some industrial applications, computer chip manufacturing. The electronics revolution has basically changed the way that we live today. Electronics is everywhere. All the computers, our phones, it's brought the world closer together, right? I mean, we are on this call today because of the electronics that are used both in communication networks, in our computers, our displays. Without it, we would not be having this conversation. But without optics and photonics, the electronics technology would not exist as it does today. And this is the last time I updated this slide. It says the next generation of computer chip technology uses extreme ultraviolet light. This is now going into production today for the 5 nanometer production node. And basically, this is an EUV system. It's got a very complicated light source. The light source is a laser produced plasma. They basically take a 2 kilowatt, actually a couple of 2 kilowatt lasers, CO2 lasers, and they, like they did with the fusion, they basically have a droplet of molten tin, small 5 micron diameter droplet of molten tin that drops into a vacuum. And then they focus the laser beam onto that tin and use that to generate the X-rays and the extreme ultraviolet light at 13 nanometers. And they do that 100,000 times a second to create the light source. That EUV light is collected and it bounces off of about 7 or 8 mirrors, off of a reticle that has a pattern on it that you're trying to reproduce at the wafer, and then it exposes your wafer and puts the pattern on it. You can see up in the upper right-hand corner here, some lines and spaces at a 22 nanometer half pitch, 11 nanometers. So these are 22 nanometer features right here. And those are then etched into the silicon, or they're implanted with ions to develop the memory and the microprocessors that we use today. These tools cost around $130 million each. And when you ship it, it takes up the entire cargo capacity of a Boeing jet. So these are large and expensive systems now being installed and put into routine production for our next generation computer chips. To bring things even cheaper, lower power consumption, higher processing capability, so that the power that's in our phone today is the equivalent of what we were able to do with our laptops 3 years ago. They're just getting more and more powerful. Very exciting area right now as we try to even move this even further to smaller and smaller features. Another area is in manufacturing. If you take a look at this stent, the traditional way of manufacturing this stent is to machine it. And if you look at the amount of material, if you started with a cylinder of metal and machined it out, you're throwing away 98% of the material, just completely wasteful. So a lot of medical applications take advantage of different manufacturing techniques. Aerospace applications and even optics are being made in different ways called additive manufacturing. And I'm going to play a video here which will kind of give you a sense of what additive manufacturing is all about. And we're going to hope this works.
For thousands of years, manufacturing has been guided by the same principle. We'll take a block of material, we'll machine or we'll carve or we'll chisel, we'll remove excess material from it until we get to the final shape. It's not much different from a hunter way back in time takes a larger rock and breaks it into pieces trying to make an arrowhead. Even though we're using high-tech machining methods, the underlying principle is basically the same. But there's been a revolution in manufacturing. Today, we can start with nothing and build an object from the bottom up only using the material that we need. 3D printing is so revolutionary because of the efficiency of the process. We start with a flat bed of metal powder. Powder is our ink. The laser melts a thin layer of the metal. The bed drops a fraction of an inch. We put fresh powder over the top, and then we melt another layer until you have thousands upon thousands of layers to make an actual component. This gives us almost unlimited design flexibility. If you look at the vent tube that we made for NASA's Orion space capsule, originally they took multiple pieces and then assembled them together to make this one part. Each one of those fastening points creates a weak point in the structure. The beauty of 3D printing is we're able to print it all in one piece. For example, we actually print the screen integrally into the part as we build it, making it a much stronger, much more efficient structure than you could before. One of the issues with traditional manufacturing is I can't physically remove the material that I want to remove because the machinery isn't capable of doing it. We can take that traditionally manufactured part, feed that into a computer program that looks at the loads and the environment that that part operates to reveal the true structure so that you only print material where you need it. And what often happens in these optimized designs is they're very curved and organic looking, like they were grown from roots of a tree. I mean, there's a reason a tree looks like it does. It's because it's an efficient structure. Nature is the ultimate designer. Now I have a lighter weight part which goes on an airplane, which means it burns less fuel, which ultimately means a greener Earth going forward. If you look at certain science fiction depictions of what the future is going to look like with 3D printing, all of a sudden these things become reality. For example, let's say today I have a building panel. What if I can make that panel hollow? It could be lighter, so it could be taller. It could be insulative, so that it can operate more efficiently. Instead of a 100-story building, maybe we make a 300-story building. We can now design structures with almost unlimited customization. You can custom make medical components, knees and hips, different for each person. We see cars that are custom designed by individuals versus mass produced for everybody. If you can dream it up on a computer screen, you can print it very quickly. We're approaching the point where our only limitation will be our imagination.
All right, an exciting, potential, with this, 3D printing and laser sintering of materials. It reduces cost. It actually improves safety because you don't have a lot of weak points of welds. Wonderful, capability being advanced every day. I'm going to switch gears again, talk a little bit about safety and security. And so, thermal imagers save lives, especially for first responders going into a fire. I mean, for one, you want to be able to see inside a smoky room, see if there's any people in there, to go in and rescue them. But a lot of thermal imagers are very expensive. That thermal imager that is shown right here, and I don't know why my screen has this handwriting noise on it. I apologize for that. But this camera right here is a $30,000 camera. And a lot of fire stations, first responders, they just can't afford to have that many. So each fire station might have one. In some cases, you may have one for a group of fire stations. So wouldn't it be great if you could have a lower cost thermal imager? So what I want to do now is show another video of a $300 thermal camera. So here, this is a small 60 by 80 pixel device, and as you can see, kind of no matter where you walk, you can't hide. Here's an interesting one with a shower. I was 5 feet tall. You always complain the water's never hot. I'm 6 feet tall, so I'm always up near the head of the shower and never have a complaint. Here we can show that a washing pot actually does come to a boil. So now imagine having a technology where I basically take that thermal imager that's $300, maybe make it a little bit more robust, and every first responder can have access to one of these thermal cameras, improving safety, making it easier to rescue people, but also protecting their own lives. This will happen in a very short amount of time. Again, all brought to you by combinations of this optical lithography that I talked about before, as well as other optical technology being developed to lower the cost of these devices. Automotive safety. You look at the typical automobile today, and it's got a lot of optics and photonics technology in it already. Sensors to control the distance between two cars. So basically assisted, cruise control. Going forward, they're saying that cars may have up to 11 cameras on them. So you have a rear imaging and a backup camera, prevents you from, backing up over some child is playing behind you. The adaptive cruise control, the LiDAR now that's being developed, infrared LiDAR, basically for semi-autonomous vehicles. Again, much, much better control. And so what you're seeing here is a short video from Luminar Technologies, basically showing the images that you can get coming out of a car, and that way you can also, guide the car through traffic, through intersections. Again, the whole concept is to improve automotive safety and reduce the number of accidents that happen, the number of people that get killed every year, with blind spot detection and all sorts of activities going on in this field to try to make our cars even safer than they are today. Not having to rely so much on human judgment as to whether or not to avoid conflict. Cars, computer systems can respond to braking much faster than people can. All right, so this one I'm going to play a video. You're going to see people talking, but you're not going to hear anything. I'm not actually playing the sound on this one. And I want you to kind of try to think about, from this particular video, it's a public service announcement that was done in the UK. And, try to get a sense if you can figure out what is happening. If you have some ideas, go ahead and post them in the chat. And then when the video finishes up, I'll share, if you haven't figured it out yet, I'll share with you what it's about. So kind of pay particular attention to the billboard. There's a couple of different sections on the billboard where things are happening, and try to think about how optics and photonics might be involved here. Anybody have any ideas? See the red bar going across? See the little red dots on people's faces? All right. So this is a public service announcement that was put together in the UK. And what you have is people going into a very heavily trafficked building. And you have this electronic billboard, above, and you have this person. And so basically, what is happening is that you are looking at a woman who has been beaten. So she's been, beaten on her face and she's got bruises, and so her husband or, boyfriend or something. And the bottom portion of the video was showing cameras looking out at the people coming in and out of the building. And it was using eye tracking. And so when you saw the little red dots on people's eyes, those people with the red dots on their, were actually looking at the billboard. And as people looked at the billboard and saw the woman, over time, her bruises would heal. So if everybody was walking in and out of that building, looking down at the ground and not looking at the billboard, she would stay bruised for an extensive period of time. But as people looked up and watched, her bruises healed. And then at the end, her bruises are gone and she thanks you for seeing her. So domestic violence is one of the most, hidden, hidden things out there. And this is trying to bring awareness to it so that people look out for domestic violence and bring attention to it in society, that this is something that we have to eliminate. And I thought this was just a kind of a fascinating use of video technology, eye tracking, to bring awareness to something such as domestic violence. Also looking at health, health. This one is very important to me personally. This is a video showing a pill cam, which is a small camera. It's about 1 centimeter diameter. You swallow it, and it'll go down, and it'll basically take images of your upper intestine and your esophagus as it travels through. The photo up here in the upper right-hand corner is an endoscope that is used for colonoscopy. My family, we have a history of colon cancer. My dad passed away when he was 53. I was 15, so I was a sophomore in high school at the time. And he was actually misdiagnosed for about a year. And he suffered for 3 years going through chemotherapy, radiation treatment before he passed away again when I was 15 and when he was 53. My mother also passed away when she was 57 from colon cancer. And we have now come a long way in diagnosing colon cancer, and it's the most preventable form of cancer that is out there, because all you need to do is get routine colonoscopies periodically. So I had my first colonoscopy when I was 30 years old. Our health insurance company at the time said, "Oh my, you have this family history, and you should go get tested." When I was 30, I was fine. I had my next colonoscopy when I was 44, and I had 2 polyps. And the way colon cancer forms is that you develop polyps in your colon, and they grow, and then they become cancerous. You get sick, and if not treated, you pass away. And so I had 2 of these polyps. They had not turned into cancer yet, and they simply removed them, and I went on. And then, of course, I got colonoscopies the next year and 3 years. So I just had my 5th one a couple of weeks ago, actually. And without this endoscopy procedure, the polyps that they found when I was 44, would have ultimately turned into cancer, and probably at about the same age that my dad was at 53, I probably would have passed away. So I'm now 57, almost 58. So because of endoscopy and colonoscopy, I am actually here with you today, and I might not be otherwise. All right. no good way to do this, but there are a lot of people in the world, including me, and probably many of you, who without corrective lenses of some sort, this is what the world looks like. Very, very blurry. In a lot of places in the world, we have very good access to prescription eyeglasses, right? I have a pair here that are actually bifocal in nature, so that I can see the computer screen read, see at a distance. I have very, very strong astigmatism. I can correct it with no problem. People have access to contact lenses, and in some places, they even have access to laser corrective eye surgery. I would have loved to have gotten rid of eyeglasses and had laser corrective eye surgery, but I have so much astigmatism that until a few years ago in the United States, it wasn't authorized to treat my level of astigmatism. When it finally was approved for my level of astigmatism, my ophthalmologist tell me that I'm too old, to get the procedure because my eyes are going to continue changing and needing the reading glasses and stuff like that. So such is life. But there are roughly over 1 billion people in the world that do not have access to eyeglasses for various reasons. Not enough optometrists, they're too expensive, can't get the, they can't get the corrections that they need. And so there are a number of institutions around the world that are trying to address this. And I'm gonna share, hopefully you guys will all be able to hear this video as well.
My dream in my future.
I would like to be an engineer.
My future dream is to become a surgeon.
I would like to be a lecturer, a university teacher.
My dream is to become a neurosurgeon because in our country the doctors are very few and the patients are suffering.
My dream for the future is that everyone has good vision so that they can develop themselves to the fullest and develop their talents, and by doing that they will be able to serve the community, themselves, the whole world.
2 Billion Eyes is a foundation based in the Netherlands, and recently a small team traveled to Kenya where they visited schools and hospitals. In the schools they conducted eye examinations. Each student helped to assemble their own pair of glasses instantly. They could each choose the color of the frame and decorate it with beads of their choice. 2 Billion Eyes will be training individuals in the communities to become vision technicians so that this process can continue expanding and be self-sustaining.
My dream is to become a doctor. I want to do this to help my family, nation, and the world at large.
When I grow up, I would like to be a lawyer. Together we have to make this.
I would like to help people who are in need. I would like to be a nurse.
I am grateful and happy that I will be able to see clearly than before and make my dream come true.
So about 4 years ago, I actually went on a visit to Kenya with 2 Billion Eyes. And there was a woman, we were doing a study, and she was reading something, and I could tell that she was really struggling to read. And she was about 45 years old. And we asked her if she was having struggle reading. And she, well, my eyes are old, and so there's really nothing that can be done. And so we made a measurement on her eyes, and she needed reading glasses. And so we handed her a pair of reading glasses, and she put the reading glasses on, and her eyes went really, really wide. And she reached into her purse and pulled out a small book. It was probably 3 inches by 2 inches, about this big, thick. And she opened up to a page with this really tiny font, and she started reading. And in this case, it was her Bible. And as she was reading just one passage from the Bible, she just started crying. it was pretty clear that just for the lack of reading glasses, she probably had not been able to read her Bible for years. That was just one very small impact of providing eyeglasses to somebody. I've heard stories of a family farmer who, because he didn't have eyeglasses and couldn't see, he went to plant seeds and he planted the wrong seeds. And so when he tried to, water it and raise it and stuff, it was the wrong season for it and it didn't grow and his crops failed and he had trouble feeding his family, all for want of a pair of eyeglasses. A year and a half ago, 2 Billion Eyes worked with a shipping company to provide testing and eyeglasses to truck drivers. And some of these truck drivers came in with vision that was, in the United States, would be measured as 2200. In some other parts of the world, I think that's 10% or something. Clearly unable to see the road in front of them, and yet had come in their truck. And we measured some 600, I wasn't there for this trip, but 2 Billion Eyes measured some 600 people and provided eyeglasses to about 150 of them and reading glasses as well to another 100 or so. Again, making roads safer. So what is the 2 Billion Eyes model, for trying to bring eyeglasses to low resource areas? And, one aspect of this is to do something where you don't need to have somebody train for 3 or 4 years as an optometrist. And so for that, we've partnered with a company by the name of Planoptica that makes an automated measurement system that you basically put it up to your eyes like a pair of binoculars and push a button and it measures a prescription in one eye. You then flip it over, push the button again, and you get the prescription of your other eye. And then we have a kit, and it's 2 briefcases, and one of the briefcases has everything in it that you need in terms of the tools to assemble a pair of frameless eyeglasses. The other briefcase has all the components. It has lenses, it has the bridge, it has the temple components, and all the press fits to put everything together. There's not a single screw in this design. Everything is press fit and very easy to assemble. We can accommodate various pupillary distances by the way that we orient the lenses, and we've got they've got 2 different sizes of bridges. And basically, right now, the cost to deliver a pair of eyeglasses to a person is around 10 euros or so. And that includes getting the diagnostics. It includes a little bit of income for the vision collaborator that is basically going and helping with this. And so the goal of this is to have something that is sustainable, does not rely on always rely on charitable contributions to basically provide eyeglasses. Planoptic is actually working with the Aravind Eye Institute in India as well to get eyeglasses out to the lower resource areas and the people that don't have access to a clinic to go to. Another area that is pretty exciting to me is nobody has really come up with what the killer application is for virtual and mixed reality. I guess what they're calling now XR, virtual mixed reality, augmented reality. And here are 3 different applications that are really interesting. I'll show a video for one of them. But basically, one area here that I'm not going to show the video for is experiences for the homebound. You have people in that are wheelchair bound or bed bound, and they want to get out and see things. And so with virtual reality, you can take them to Versailles in outside of Paris. You can take them to the Louvre. You can take them on a trip to the Himalayas. You can take them skydiving through a mixed reality headset. Basically give them a little bit of escape when you can't get them out otherwise. Training for pediatric trauma is another area where a lot of the training comes with physicians and surgeons, where they are side by side with a surgeon with expertise actually performing the operation on somebody. But there aren't a lot of necessarily pediatric cases to do that training. And so they're starting to use augmented reality and simulations to do that training. Another area that's really interesting is in exposure therapy for treating phobias. And this is the video that I'll play.
A spider crawls across a countertop. Using virtual reality as a therapy for people with a common phobia. Fear of spiders and other phobias affect more than 1 in 10 American adults.
They have a fight or flight response. So they get sweaty, their heart races.
They avoid what they fear, sometimes going to extremes. Like Nick Harrell, who was working on his phobia of flying.
I physically got on the plane to Paris and then got off before it took off. And I did that 2 days in a row.
Today, virtual reality therapy can help. The technology is just now reaching the mainstream after 20 years of research. It uses a proven therapy called exposure therapy, gradually exposing
back in that place, and afterwards I see like nothing terrible happened. It might have been uncomfortable, but I can handle it.
A therapist can have a patient who's afraid of heights visit a tall building or imagine themselves there. With VR, patients learn to feel safe on a virtual high-rise balcony without leaving their therapist's office.
This would have been simply impossible 3 months ago. It would have been total avoidance. I wouldn't even have attempted this.
Research shows VR can lead to gains in real life and is as effective as face-to-face exposure therapy.
It is dramatic. At the heart of fear of heights, people have this idea that something bad is going to happen, that they're going to fall off, or the buildings collapse, or they're going to jump off. And what we do in the therapy is help people to learn that that won't happen around heights. So if you change those thoughts, it leads to changes in the real world. The change is extraordinary to see. People who wouldn't look at the heights, wouldn't go up to the heights, after just 2 hours of the VR treatment, can boldly go up to the heights.
Equipment is lighter and more affordable, with tech advances spilling over from the VR gaming industry.
We've all been piggybacking on this technology that was initially developed for video gaming. It's really Christmas for VR researchers.
Next could be VR therapy without a human therapist. Researchers are studying whether animated characters in VR worlds could be as effective as human counselors. Malcolm Ritter, Associated Press.
You know, it's interesting. My nephew is a programmer and decided to develop an app actually for dealing with the fear of spiders. And he has a fear of spiders, so he started with that. And he used his own software program on his own VR headset to do this exposure therapy with a spider that first looked like a cartoon and got more and more realistic. And after doing it 10 minutes a day for about 2 weeks, he then went into a pet store and put a tarantula on his arm with no issues. And you know, he's since also done it with cockroaches, and there are obviously clearly other institutions that are doing the same thing in a lot of different areas for helping people with phobias. So just another example of how optics and photonics is being used to help us as people move forward with our lives in a much better way. And that actually concludes the formal part of this presentation. My question to you is, as you pursue your education and your careers in optics and photonics, how are you going to help make the world a better place? And I'd like to thank everybody very much. And I apologize for the annotation. I tried to get rid of it a couple of times, and I don't know where it came from, but hopefully the next time I do the talk, I'll figure that out. And at that point, I think I'd just like to turn it back over to Keshav as host and see where we go from here.
Thank you, Dr. Marc. Very interesting talk. There's lots of product which are working on optics and photonics technology. They are very futuristic. Now I request Vipinder Negi to kindly take the questions from the audience participants.
All right. And I figured out how to get rid of the annotation. Thank you. Sorry, I had to wait until the end.
I also request participants. Dr. Mark have a huge experience in corporate sector. He is into various companies. So you can also direct your question regarding project management, career development, and related topics, and also job opportunities in MKS and Newport. So I request you all to kindly make your question.
Hello.
Hello. Yeah, Dr. Gofran.
Hello, Doctor. Yeah, yes, Dr. Mark. Thank you so much for this nice presentation. I have, because I'm working in solar area. So how you are looking for this concentrated kind of thing, because it is generating a too much heat. Sometimes it's very difficult to manage the heats from that concentrator. It burns the solar cell also. It damages the solar cell also. So how we can means reduce the heat or optimize this portion?
That's a very good question. And I'm not, I presented a lot of the things I presented are areas where I don't have a lot of actual experience in the field. And solar is probably one of those. So I'd have to rely on the experts in the solar field to answer questions in terms of how to deal with the heat dissipation. When you're using the concentrators. So you probably have more expertise in this area than I do.
Okay, thank you. My another question is that the emerging material in case this photonics, emerging material like perovskite is. Are you looking that this perovskite can be a good material or be proved as a good material in case of photonics also?
Another area that I'm not actually too familiar with. I know that in some areas of optics, there's a lot of research being done in materials, chalcogenide glasses for thermal applications and stuff like that. I'm not as familiar with the perovskites to comment. Sorry.
Okay, thank you, thank you.
Any other questions? I can talk about, if you have questions about careers in general.
Yeah, you can go ahead with that.
Yeah. Okay, so we do have a question. How are the present technologies to use light as a means of communication? And clearly, optical fiber communication is, the backbone of all of our networks, today. And, one thing that's kind of interesting is the increase in everything that we're doing on the internet, especially with like all this video, calls that we're doing, today, is increasing the need to store that data. And data farms are growing and being built, and they consume a lot of energy. I think 5 years ago, data farms were consuming about 3% of worldwide energy, and it was increasing at a pretty quick rate. And one way to improve the efficiency of data farms, right now fiber is used for long haul and medium haul applications, but moving it towards short haul. In other words, basically, from board to board and computer to computer inside these data farms, to use fiber optics for that and use optical communication channels to save energy. The next level is chip to chip using optical interconnects. And so there's a lot of research that is being done in that, because now at the chip level, you have to convert the electrical signals into optical signals to transport them over to the next chip. And so that's an area of a lot of development where if you want to do silicon-based technology, how do you grow a laser using silicon or materials that are compatible with CMOS type processes in a semiconductor fab, or do you build a laser in another material using 3.5s and bond them and stuff like that, trying to find a low-cost means to do that. Other areas where optical technology is being developed for communication is in free space optical communication. I think Google was talking about using it on balloons to bring internet to areas that didn't have access. And most of their loon applications are actually using radio frequency instead. But Google does have projects in various parts of the world where they are mounting free space optical components on the top of poles to do communication, to bring internet to areas. And an interesting aspect of that is in some countries, ownership of property, they can basically, I own this acre of property. I don't want you digging a hole and running a cable, across my property. And so on the edges of the property, they put up 2 poles and use free space optical communications there, to get rid of some of the legal issues with that. So those are some of the areas, for communication that are moving forward. And there you're talking about propagating a laser for a kilometer or 2 and having to keep things tracked so that it stays aligned. And so you have a lot of automated alignment systems in there as well. I think this question is in the chat is if free space optical technology is promising. And in some specific applications, I think it is. It's going to be very dependent on the application. There are people that are working on free space optical communications to bring internet to my computer in my home. So using a light, some sort of a light bulb and stuff like that. Whether or not that is something that's really cost effective over using traditional Wi-Fi technology, I don't yet know. But again, in certain applications, maybe some satellite communications, you might be able to get higher bandwidth by using free space optics than using radio technology in space. Or like I said, in these applications, between buildings or between poles, there are certain applications where it might be a cost-effective solution.
Hello.
Yeah.
Yes.
Oh, so do you hear me?
Yeah, your
Yes.
voice is audible.
Oh, okay. So I have a question. Could you discuss something about what are the various possibilities and challenges you prospect within next 10 to 20 years?
I think that it's kind of hard to say. I'm not a very good predictor. I'm not a very good predictor.
No. Sir, I'm asking this question particularly because you actually showed that what are the strength of optics and how optics is touching every area of our daily life. And it is really fascinating to see that like the pill you have shown and other areas. Likewise, I was having like of imagination what would be the future in terms of next 10 to 20 years.
I mean, I'll give certainly give some thought.
From your perspective.
So in the areas that I talked about, I mean, for one, lithography. So we keep asking ourselves the question of when will scaling in lithography come to an end, so that our computer chips won't get any more sophisticated or power levels and stuff like that. And I remember getting asked this question when lithography was at a quarter micron, 250 nanometers, and would it go any further than that? And now we are going to 5 nanometers. And so I actually see this continuing. We may end up with some strange effects where we have to deal with quantum issues with single nanometer scaled structures. I'm always just amazed when you look at the technology that goes into the computer chip manufacturing. This $130 million tool is producing 5 nanometer structures. It's aligning them to each other layer by layer, and you're building up, say, 40 layers of these things, and it's aligning them to maybe 1 nanometer. And it's doing this at 100 wafers an hour. So these wafers are moving, in this case in vacuum, at 1 or 2 meters per second. The mask is moving at 4 times faster than the wafer because you're demagnifying. and they're keeping these things locked together to this nanometer level. And that technology is going to continue to improve. As we're seeing with, quantum computing, and, this is another one of those things I think that could prove super, super useful, or it could be like fusion and fusion power and always be 50 years, in the future. It is hard to say, what's going to happen with quantum computing, and does it bring kind of a real change to the types of things that we can do. But if you imagine, if we continue down the roads of improving our computation capability, the ability to do simulations significantly improves. It becomes faster. So combining a whole bunch of things together, right? So satellite measurements of various wavelengths, various things around the Earth, Earth-based measurements, huge amounts of data looking at temperature profiles as a function of depth across the ocean, in the atmosphere, wind patterns, all the ability to bring these things together, huge, huge, huge amounts of data, and process them into better and better simulations to make better and better predictions of weather patterns, whether we're talking about climate change or whether we're talking about the path that a hurricane is going to take. I live in Florida, and so we're always wondering where the hurricane is going to go. And the majority of the time, people that live on the beach are told to evacuate the beach because a hurricane is coming, and then it curves to the north and it misses the coast and it goes and hits someplace else where they weren't prepared. And at some point, the more and more times you get told to evacuate and nothing happens, the next time they tell you to evacuate, you're going to go, why? And then the hurricane is going to come and hit you. So the better that we can predict, that, the better off we are. And so I think that will continue to improve. All combining a lot of these technologies together in more efficient ways. Healthcare. I think 50 years from now, when people look back at how we treat cancer, they will think that we are barbarians. Because what do we do most of the time? We basically say, okay, we've got a cancer cell, so we're going to expose it to radiation, and we're going to expose it to deadly chemicals, and we are going to hope that we kill the cancer before we kill the person. And everybody who goes through chemo and radiation therapy suffers tremendously. It's painful, you get sick, and it's barbaric in terms of what we do, but it's what we have. And optics is playing a role in, basically being able to make more targeted, treatments. Nanoparticles is a fascinating area of potential, but our body is so good at fighting off invaders that the nanoparticles don't get to where you want them to go. The body builds up these antibodies and goes and attacks them and destroys them before it gets there. And there are technologies now that are being developed that actually temporarily kind of weaken the body's immune response to a particular type of invader, that then allow you to get these targeted nanostructured devices to the tumor area at a higher rate, and then using heat or thermal lasing technology to then heat and kill the cancer and stuff like that. I think these types of treatments will improve. So 50 years from now, we will have much better methods of treatment for cancer. Right now, the world is a scary place, right? I mean, we've got a pandemic that is out of control in many parts of the world. It is certainly out of control in the United States. It is, out of control in certain parts of India, where all of you are. And optics and photonics is actually playing a critical role in dealing with this COVID disease, in terms of the filters that are necessary, the optical tools that are necessary to do testing. In some cases, even optical technologies involved in developing the treatments, looking at fluorescing materials to see whether or not it's doing what it's supposed to be doing, and stuff with the antibodies and stuff like that. And that will continue going forward. I think our communication capabilities will continue to improve, more and more bandwidth, and certainly now, as we see with where we are today, most of you have your cameras off right now because it would take up too much bandwidth to do the presentation. as we improve bandwidth around the world through optical technology, we'll actually all be able to have these meetings with 50 people, with all their videos going at the same time, and you won't see a lot of lag. 5G communication, reducing lag. One of the things, with medicine is right now in a lot of situations, you need to bring the patient and the doctor together, especially for surgeries. So if I want the best surgeon, to do a heart transplant or some critical operation that's maybe a new methodology, I've got the doctor and the patient have to be together. Imagine if that could be done remotely. So you have some robotic treatments, and the doctor, who is the expert, is in a hospital where he is. I'm in the hospital where I am. Maybe we're thousands of kilometers apart, and he's controlling things, through, say, augmented reality with a robot structure, to go in and actually do the surgery. But right now, the lag time is too long. A 50 millisecond lag time with surgery could mean the difference between life and death in a complex operation. So if we can reduce that lag time down, then you can have, remote surgeries that are much more practical. I think we saw today that the lag between the video and the audio on today's presentation was maybe a second. I was watching this on the same, on a different computer, watching what you guys were all seeing. And on my computer, where I'm showing the video, everything was really smooth, everything tracked really well together. On my other laptop, it was choppy, and so I could only imagine what you were experiencing. So those are just some ideas.
Thank you. Thank you for answering the question. And I think there is another question from the chat box. Laser uses a concentrated beam of light. So if something comes in the path, it is blocked. If I am to transfer data using a laser beam, what are the measures to overcome it?
So, that is a problem, and that's a hard one to overcome. In some cases, they might use multiple wavelengths in very different bands. So say a near visible and an infrared wavelength that can propagate through different types of media in terms of fog and clouds and stuff like that. But it is one of the big, limitations. It's kind of like satellite television. It used to be you'd have your antenna on your roof looking up and getting information from the satellite. And so anytime it rained, your signal went away and you couldn't watch your movie. And so that is one of the drawbacks of free space optical communication. Is basically if something blocks the beam. If somebody builds a building between the two towers, then okay, you can get around that by putting another tower in, I guess. But if you live in an area where you have a lot of fog, then yeah, you're going to have issues with that type of technology being consistent. It just means putting things closer together. So more nodes, maybe wavelengths that propagate better through water vapor than others, to continue to use that.
Any other question, please? Anyone can ask and unmute their mic to ask question, or they can type into the chat box.
Okay, Dr. Marc, I have a question regarding job employability in MKS and Newport. So I'm a PhD scholar here. So what are the skill set and eligibilities which are MKS and Newport are looking for getting employed, scholar get employed?
Yeah, I mean, the qualifications, what we look for is very different depending on what role you play within the organization. So I run an inside sales team, and our goal is basically to sell our products. We work mostly as Newport Corporation. I'm sure you're aware, we have a lot of off-the-shelf catalog type components, but we also do customization. And so my team of inside sales, one of the things we're trying to do now is, anything that can be sold inside without a field salesperson needing to come and visit. we're trying to bring inside as much as we can, to leverage that capability within our organization. And so, the role that we have in my team, anywhere from somebody with a 4-year degree in optics, electrical engineering, or mechanical engineering, through people with PhDs and several years of experience, are of interest, to my team. So I have people with PhDs in optics, and I have people with 4-year degrees in optics and photonics and mechanical and electrical as well, because we cover things like motion control, vibration isolation, instrumentation, as well as conventional optics. On the product side, where you're doing product development, similar. We have need for electrical engineers, mechanical engineers, systems engineers, with various ranges of background. Again, from bachelor's degrees to PhDs. We usually like to have people with a few years of experience, but in some roles we bring people in straight out of school, as well. We have facilities throughout the world. We have a lot in the United States, in California, and Massachusetts, looking at the MKS side of the business as well as the Newport side of the business, in France and other parts of Europe, as well. Typically, for the positions in the United States, we do want to have somebody that is a green card or a citizen. We have some facilities where that's not a requirement. Just kind of depends both on the facility and the particulars of the role. So I run a small office. I've got people in California as well as people here in Orlando, Florida. We actually have one person who is from Mexico and currently on a visa that we were able to hire, because we don't get involved in any of the export controlled or restricted type of work. I look for more than just what the degree is. I look for people that have the ability to develop rapport with customers. I look for people that can project a truthfulness and a trustworthiness to our customers, so that we want to develop types of real partnerships with our customers and work with them very closely to solve their problems.
Okay, thank you.
And Kashaf, for any specifics on a role, you can go to the MKS website and go to the career page, and you can see all the openings at the various divisions, both our light and motion division, which is Newport and Ophir and Spectrophysics, the MKS division, which is vacuum and analysis equipment, as well as like our electronic solutions business, which is actually equipment that's used for materials processing, glass cutting, and machining.
Okay, thank you. Any other question? Okay.
Keshav, I think there are no more questions in the chat box, so I think we can conclude.
Okay. Okay. I request Amit Pandey to give a thanks note to our speaker.
Hello, sir. I have assigned duty to thank you. I would like to thank our eminent speaker, Dr. Marc Himel, for giving us such interesting and fascinating lecture on harnessing the light for better world. Thank you, sir, for enlightening us by your vast experience in the area of optics and photonics. Thank you once again. I would like to thank our faculty advisor, Dr. Umesh Tiwari, for their presence and constant support to us. Thank you, sir.
And thank you.
On behalf of our, thank you.
Go ahead.
On behalf of our chapter, I also thankful for all participants and members of our SPI chapter, student chapter, Chandigarh.
Thank you, Amit.
All right, thank you, Amit. And it was a pleasure. And I hope that sometime in the future we can meet face to face. I look forward to, that opportunity. And I hope you found the time worthwhile. And if you have any questions, Kashad knows how to get a hold of me. Feel free to send me an email with any questions you have, and I'll be happy to respond. If you want to have a discussion, a one-on-one discussion with me about careers or anything, we can arrange that as well. So thank you very much for this opportunity, and I look forward to seeing you all again at some conference someplace.
Yeah, sure. I request everyone to kindly switch on their camera so that we can have a digital selfie with the speaker. Kindly switch on your camera. Okay. Okay. Let's take a selfie. Thank you. Thank you everyone for for attending the talk, and I thank you, Dr. Marc, for sparing time, his valuable time to deliver the talk. Thank you to everyone. This talk is concluded. Thank you.
All right. Thank you. Have a good evening, good night, and a great weekend.
Have a good day,
Thank you,
Dr.
sir.
Marc.
Thank you.